Often when you have a faculty member teach a course, they talk about their research. Well, back in the day, this is something that I worked on at British Petroleum, corrosion, and it ended up being a chapter in a book, The Corrosion of Iron. So, corrosion is section 20.8, and corrosion is a redox reaction. It is an unwanted voltaic reaction, and it is a spontaneous reaction, just what you've learned in the beginning of this chapter. A metal, let's say iron, is attacked by some substance in the environment, let's say oxygen and water, and it's converted to an unwanted compound. And by that I mean these ions listed for iron. For almost all metals, oxidation is thermodynamically favored in air at room temperature, and what you make is the metal oxide, Fe2O3. If you do not inhibit oxidation, it can be destructive. And what I try to do is put a picture of one of my favorite bridges in Cleveland, the one that goes up and down. We used to go eat lunch there and watch the traffic go on the river. That's long time ago, before the flats became gentrified, okay? So rust has the formula Fe2O3.XH2O, and we're going to address now, why does it form? Well, what is iron? Well, it's an element, you know that from here, but up to 20% of what is produced every year replaces current structures. If you see a crumbling bridge, or if you have rebar in a road, that is the iron solid that has turned into iron oxide. It's turned into rust. If we look at these two reactions, notice how this is more positive. This is going to become the reduction. Notice that by default, this is more negative, and it becomes the oxidation. And the oxidation here takes iron as a solid to make the unwanted ion iron 2+. To add insult to injury, this reaction is sensitive to H+, and by that I mean acid rain in the atmosphere, and then you cannot stop it. Fe2+ further oxidizes to Fe3+, and there is our formula for rust. Okay? If you want to prevent the corrosion of iron, and now you know about E0 reduction and the role it plays in redox, you can use one technique called cathodic protection. And that is where you use a sacrificial anode. You choose something that has a lower E0 of reduction so that it will preferentially oxidize. And cathodic protection works until the metal is all used up. Often, if you live in an area that is very old and it would be too expensive to replace all of the iron pipes, what they will do is they will come in and they will put in a sacrificial magnesium anode to keep that pipe from further corroding. It's kind of important in terms of gas lines. You know, those explosions we've heard about on the East Coast, that was really the breakdown of the pipes, and you saw what happened. That's the first thing, cathodic protection. The second is you can put a coating on there. Notice tin has a more positive reduction potential, and to be honest, it doesn't kind of go by the same mechanism, but it will work as long as there are no holes. If you've ever seen a can of tomato paste, tomato sauce, or a tomato product, it tends to be very acidic, and the acid could attack the container. So what you do is you put a coating on there so that it does not become attacked. So again, corrosion of iron with cathodic protection, corrosion of tin, to protect tin from undergoing corrosion, you can put on a coating. So I guess I should have separated those. Okay. Anyway, the third way you can minimize corrosion is to use an alloy. And that's what they normally do when they make a structure or they make a pipe. Perhaps you've heard of stainless steel. Stainless steel is really iron, but what it has in it, has about 11% chromium in it. There's many different formulations, and it is used to prevent rusting. So the little picture here on the right, that is a phase diagram, much more complicated than anything we saw in the past in Gen Chem, but in the real world, these things play a real role. Anybody in our class that's a material scientist, you will specialize in this as you're earning your degree. Finally, why does aluminum rust at all? And I write, did you ever see a rusty Coke or a Pepsi can? Absolutely not. Well, how do we explain that? Aluminum has an extremely negative reduction potential. It readily oxidizes to form Al3+. But unlike rust, which does not form an imperious coating, aluminum forms this imperious oxide coating, Al2O3, and what it looks like under a microscope are antlers, the kind of antlers you would see on a deer. And that makes a torturous path for anything trying to attack the aluminum surface. So I couldn't leave this section without talking a little bit about what I used to do. And essentially, one of the groups I worked in was in corrosion resistance, and we were really concerned with the electrochemical properties. We were concerned with the physical properties. There was another group of engineers concerned with the metallurgical properties. But what I wanted to point out to everybody is real life is not like this Gen Chem course. If you have a material that you're trying to turn into a product, you have to worry about corrosion. You have to worry, is the material available? What kind of strength does it have? Can I fabricate it? Can I make it look good? And possibly the most important is the cost. So I rarely think anybody is going to, do general chemistry, but you may be involved in something in your career where all of these components come into play. Finally, to wrap this up, back to slide 1. It had 2 half-cell reactions. It had a summation reaction, which described, I'll call it the net reaction. We really can't balance it per se, but that is the reaction that forms rust. To walk you through it as we depart, iron is oxidized at the anode region of a metal. The electrons from the iron migrate to a region acting as a cathode. Oxygen is reduced at the cathode region, and finally, Fe2+ is oxidized more to form Fe3+. There's a lot of chemistry involved, and there isn't a traditional cell like we've seen. All you need is a spot on the metal for this process to take place. So when we talk about cathodic protection, it is to prevent that from occurring. When we talk about putting on a coating, the coating is there to make a more tortuous path to get to the metal. And finally, if we have an alloy, we are building inside that metal the ability to resist corrosion.